G'day, and thank you so much for choosing True Blue Solar Co to be a trusted service provider. In this video, I'm going to give you a live walk through the mySigen app so that you can get a better understanding for what to expect to be able to read now that you've got your solar and battery system set up inside of this app. We're going to use an existing client of ours' site to demonstrate what you can see in the app, because your app won't have any data in there for at least a few days for us to be able to describe what's going on inside of it. So here we go here. We've got a customer of ours, Julie, and Julie, the first thing we'll go through here is just got obviously system and device. So you got device here if you want to check the battery characteristics, and the panels and the gateway just there. Sort of a lot of details. We won't go through everything, otherwise we'll be here for hours. Back into the system here on the left-hand side, we've got this little sort of picture of your house, so to speak. We've got the battery, the gateway, the grid, the house, and the solar. So on this one right now at 10 o'clock in the morning on the 19th of October, we've got 7.6 kilowatts of PV being produced. This site has, I think it's got around about 12 kilowatts of solar panels in total. So what's happening is we've got a little bit going into the house, about 1 kilowatt, and the excess being sent into the grid, because the battery, as you can see here, is already 100% charged. Now on these two graphs here are interlinked, and you can scroll through them like so. So this one here is current, today's date. I'm going to use this graph here to explain the readings, because it's got a full day of data for us. So we'll start down here. We've got our 4 colors. So we've got solar produced, battery, grid, and load consumed. So you can turn them on and off, however you see fit. If you want to see one thing by itself or something like that, whatever suits you. On the horizontal axis here, we've got time. And then on the vertical axis here, we've got power in kilowatts. Down below the line, this is the 0 line here. Below is negative, so that means energy going into the grid or into the battery. And here above the line is positive, which means we got energy coming out of the battery or solar energy being produced. Now, if the grid, the blue is above the line, that means you're actually consuming energy from the grid. And we can't see that on this graph because there was no energy consumed from the grid on this particular day. So this is early in the morning and midnight, basically, 4 a.m., 8 a.m., middle of the day, in the afternoon, and then all the way through to the night. So as you can see, you got your solar starts kicking in around about 6:50, 7 o'clock in the morning, slowly climbs up, reaches 10 kilowatts roughly in the middle of the day there, and then creeps down. That's your solar production in the yellow. Now, what's happening here is the solar is basically pretty much just going straight into the house, filling the load in here. And then the load consumption here is slightly larger than what the solar is producing. So you've got a mixture of battery and solar supplying the load there. As you can see on that point, it's got the summary above with the 4 dots there. So you can see grid imported equals 0. The load consumed equals 2.7. And the load consumed equals both the solar produced plus the battery discharged. As you can see, the battery is continually charging for about 3 hours, I would say, from 7:30 till 10 a.m., so 2.5 hours. And at that point there, it's basically fully charged. Now, the battery might have only charged 20 kilowatt hours or so in that time, because it probably didn't discharge completely over the night from the previous day. As you can see, this house in this period of time in the evening and middle of the night is using bugger all power. So because it's October, they're probably not really flogging their air conditioner or underfloor heating or anything like that to keep the the house at a comfortable temperature. So you can see like the load's only 0.5 kilowatt, just all real basic base loads like Wi-Fi circuits and fridges and stuff like that. So that's these graphs. Now, as I said, you can click through the days there to sort of compare, yesterday to today and whatever you want to do. And above here is just a direct reflection of this in a summary of a different type of display. You can click through these buttons here to see a weekly view, a monthly view, yearly view, and lifetime. Whatever suits you, you can click through those details and see that. That's probably the most important thing to cover. Here's just basically what you see above summarized in text. And down here, you'll see a energy value. Now, to get this even close to correct, you have to import your billing details. You're probably not going to sit there every single time your energy retailer changes their tariff and update your app. So up to you how serious and how close you want to get this to be. But this is mainly just to make sure, this app is to make sure that your solar doesn't have a fault on it. I recommend you check it once a month. It takes you 2 seconds when you get home from work once a month to just look at your app, make sure that solar's been producing properly and there's no problems. You'll be able to see very obviously if there's something wrong. And then you've got your battery state of charge. That's an important one. Usable capacity is 24 kilowatt hours for this battery. And then you've got your battery charge there. So basically, this is how it's been charging. You can click through and see all the different types of stuff in here. Now, one of the important things that you'll want to know about is potentially how to connect to a VPP. So to do that, you're going to need to get onto your VPP operator and ask them how to connect your system. Now, generally, what they're going to do is they're going to ask for, if it's a Sigenergy battery, for you to give them this system identification number here. Once you've given that to them, they will connect to your system. Then you'll be able to click into operational mode here, click current mode, and there'll be another operational mode here for the VPP that you want to connect to once they've connected to your system and you've given them that number. At the moment, this system doesn't have one because this client is not using a virtual power plant. Now, what I'll do is I will show you another job where the system is connected to a VPP. So you can see here, VPP scheduling amber, and you can see that the operational mode for the virtual power plant is available for this site. And then once you've obviously got that operational mode available, you need to select it and enable it, okay? Now, this one, you can expect these graphs to look significantly different when you're connected to a VPP. As you can see here, the solar just ramps down to match the load, because once you get out to October, November, the solar exporting in the middle of the day can sometimes actually cost money depending on the VPP. So the system obviously has AI built into it, and it's going to say, well, the price of electricity is negative. Don't export power right now. Just keep it inside the meter and just let out what's needed to feed the house with the electricity it's needed. And then you can see this crazy load here is just absolutely flogged the electricity out of the battery into the grid. So it's exporting 22 kilowatt hours or 20 kilowatt hours of power here after it's fed the house with what it needs, and then put an extra 20 kilowatts into the grid. So, from the hour of basically 6:50 through to about 8:30. So for an hour and a half, that just absolutely pumped electricity out into the grid. And yeah, they would have made some money out of doing that. And if you program your system to do that, you'll be able to see with Amber, it should do this automatically for you. You can see here, like, basically in this day they made $12 $3.38, which is pretty crazy when you think about it. Not every day is that good, but I mean, if you did 365 times 12, that's $4,380 worth of credit per year. And that's also providing electricity to the house with no expense, minus membership fees and daily supply charges for the VPP operator, which would be probably $500 or $600 a year. So it's crazy the potential that these VPPs have. So I recommend you check them out. That is pretty much everything that we need to go to. If you ever see like your battery is like nearly fully charged, and there's still electricity going into the grid and it's not using all of the solar to charge the battery up, don't be alarmed. It's just like battery energy systems, when they're close to fully charged, they don't like taking in too much grunt from the panels. So they might just slow their charge rate down to ensure the battery doesn't get overcharged. That's pretty much all you'll need to know. So yeah, again, thanks for choosing us to do the job for you. We hope that you have a great experience with your making a switch to a battery system for your home. And if you have any questions, feel free to reach out. We'd be more than happy to help. Thank you.